So today we're going to talk about the periodic table. I want to go over some basics. Here is the periodic table we use in class. The first thing you notice is the key at the top. The key includes the atomic number, the element symbol, and the element's name. The atomic number is the biggest number on the periodic table. It is, of course, the most important because it's what identifies the element. It's the number of protons. Then you have the element symbol and the element's name. This example here is sodium, and you'll notice sodium begins with an S, and the element symbol is Na. Sometimes the element symbol is the Greek or Latin name for the element, so don't be thrown by that. If you look over here, you can see potassium, for example, is K, and iron is Fe. That's like barium in Latin. So this is so that people from all over the world can communicate and use the same element symbol. If you ever get confused, the element's name is 99% of the time on there. The last number on this periodic table is the average atomic mass. We're going to use this a lot more in the year when we get to some math of chemistry, but for now, just remember it's the average mass, the average weighted mass of all of the isotopes on the planet. You'll then notice there's some numbers on the side and some numbers on the top, and there's some blocks up here and blocks down here, and I'm going to go through what some of those are. Here's another picture of a periodic table. This is in color. If you go on the internet and you look up periodic tables, there's probably millions of pictures of periodic tables. What these colors are showing are the different groups of the periodic table. Now, the periodic table was discovered by Mendeleev, and Mendeleev noticed properties that were similar in elements, and he put them in what we call groups. And see, it says here groups. Groups run this way. So groups on the periodic table have similar chemical properties. Group 1 is known as the alkali metals. The alkali metals, I like to remember that because I ends in, or alkali ends in I, which is kind of like a number 1. Group 2 is the alkaline earth metals. This entire area here is called the transition metals. There are some other metals here. These are called metalloids, which I'll get to in a minute. Another special group name is group 17 is the halogens. Halogen actually means the salt makers, so that's why we have Cl from NaCl. And then group 18 is the noble gases. And the noble gases are called noble gases not because they're special, but because they're like nobility and they don't hang out with the riffraff. The noble gases were the last ones to be discovered because they're not generally found in compounds with other elements. Actually, neon, argon, krypton, xenon, if you know the Greek names, it stands for new hidden strangers of the periodic table, which I think is kind of cool. Down here, you have what's called the lanthanide and actinide series, and that is not actually labeled on here. But I'll show you where those fit in a second. They're not like special because they're down here. They're just not fitting in properly, so they put them down underneath. The periodic table, depending on what one you're looking at, might have other information on it. Some periodic tables have things like electronegativity, ionization, melting points, boiling point, things like that, all listed in these blocks. This periodic table doesn't because you can click on it. It's from the internet. But I just want to warn you, you might see some other numbers someday. So groups run this way in the periodic table. Periods run this way. They run horizontally. These are called periods. So this is period 1, 2, 3, 4, 5, 6, and period 7 on the periodic table. The last thing that you might see on the periodic table is the state of matter, solid, liquid, or gas. And this is the state of matter on planet Earth at room temperature. So most of the elements are found as solids. That's why they're kind of that grayish color. There are a couple liquids and some gases there. So this periodic table has a lot of information on it. Here is another periodic table that just has the states of matter labeled. All of these blue elements, these are all the solids. The red elements are the gases, and there are just two liquids, mercury, which I have no idea why it says HA on this periodic table. It is wrong. It should say HE for mercury, and bromine are found as liquids. Now, if you're wondering why these are all grayed out, these ones are actually not found naturally. They are man-made elements, and therefore they don't really have a state of matter. And we talked about why that is, because they're big, because they're very big and unstable. And if you look back on this periodic table, this green color here means that they're not found in nature. And I'm sorry, there's mercury is Hg. No idea why that periodic table is wrong. Maybe it's just not, the G's don't go down all the way. Here's another periodic table, again with colors. You can see here is the alkali metals, the alkaline earth metals. The reason I wanted to show you this was because the colors are not always the same. In fact, they're quite often different. Alkali, alkaline, halogens, noble gases. Here's the transition metals. Sometimes the transition metals sneak off into here. Sometimes they end right here, depending on which one you're looking at. And here's the lanthanide and actinide series. The lanthanide and actinide series actually fit right in here. So again, here's the way it normally looks to us with the lanthanide and actinide series underneath, but often this is just because this is how it fits nicely on a piece of paper. If you were to actually put the periodic table the way it should be, the lanthanide and actinide series fit nicely in here. You can see number 55, 56, 57, all the way to 72. So this is what the periodic table should look like, but it really just doesn't fit nicely on a piece of paper. Sometimes you'll see an arrow shown right here, like the lanthanide and actinide series. Sometimes Lu, Lr will be down there. Sometimes La, Ac will be up there. Don't let that confuse you. It's not really a big deal. Another thing you might notice is depending on when the periodic table was made or what rules they're following is how far out it will go here. This element right here, which is right here, has been discovered but not officially named yet. And that's what this is kind of reflecting in this periodic table. Again, this is the one we use in class. And the one we use in class shows, I think, nicely the lanthanide and actinide series and where they actually fit in. The last and probably the most important thing I want to show you about the periodic table is right here, this bold staircase. This bold staircase separates the metals, all right, which includes the lanthanide and actinide series, with the nonmetals. So most of the periodic table is metals. You can see these are all metals, and a little bit of the periodic table is nonmetals. Now, before you dismiss the nonmetals, you've got carbon, nitrogen, oxygen, sulfur, fluorine, chlorine. These are some really important elements, especially for life. There's one other little tricky thing. There is a nonmetal that hangs out over on the metal side, and that's hydrogen. And we'll get into the whys of that later, but hydrogen is a nonmetal. The rest of these are all metals on the periodic table, even these ones down here. And as far as these ones that are just discovered, the jury's kind of out on what kind of properties they will have. I want to show you what the periodic table, what the elements actually look like. This is a guy named Theodore Gray, and he collects elements, and he has a collection of all of the elements on Earth, or as many as he can have anyways. You'll notice he doesn't have any of the man-made ones. You can notice one thing by looking at this. Most of them are just silvery metals, right? So whether it be, you know, here's scandium, or here's calcium, A lot of them are just these silvery metals. Now, these are pure, right? This is the pure elements. We know something like calcium, when it's put into compounds, makes things like bones. Here's coral made out of calcium carbonate, seashells, chalk is made out of calcium. So these are the compounds, whereas, of course, this shows us the elements. Here's even mercury. Mercury is pretty famous for being a liquid metal at room temperature. So mercury is also actually pretty famous for being dangerous. That's why mercury batteries pretty much don't exist anymore, and we don't want mercury to accumulate in our fish. By the way, if you're interested in this app is, I think it runs for about $15, but it's really, really cool and you can explore all of the elements and you can obviously see them. Now, notice here are nonmetals. You'll see I like sulfur. You can see that it's very much a nonmetal. And here's some sulfur-containing compounds. There's sulfur um, in onions, and that's what gives it stinky smells. Here's our noble gases. Our noble gases like neon. Uh, Remember the spec tubes? Or if you haven't seen them yet, this is neon being lit on fire, and you can see neon lights, right? Well, other noble gases like argon, krypton, they also light up. Carbon is another pretty famous one. Carbon is what makes up diamonds, but carbon also makes up nanotubing and charcoal, and there's like little tiny carbon compounds that they now use in things. So there's a lot of different uses. So that's pretty much it. I hope that you enjoyed learning about the periodic table.